In this video, we're going to talk about the horizontal roughing pass. When we're doing a 3D path, the setup's a little different. Here I have my 3D object, which is this little half dome shape. I've also set the object on a flat surface. You really need a surface under your work. You do not want to have a shape floating in 3D because when the tool comes off the shape, it has no place to stop. The surfaces in the 3D file actually tell the cut how deep to go. So if there's nothing there, it kind of errors out and doesn't know what to do, and you can get unpredictable results. Additionally, there is a curve around the outside area of this, a closed polygon, a box in this case, around my outside shape. It does not have to go all the way to the surface. I could have just done a circle here on the surface, but this is called a bounding box. This tells the tool where to stop cutting. It's a very useful feature if I've got a large area and I only need to do 3D cutting in one specific area. I can put that bounding box around there and it'll only cut to there. It does not have to be on the surface at the bottom. It could have been higher up. Think of it as looking from the top down. This is going to be the fence where the tool stops. So to do this, I've got my piece. I'm going to go to machining operations, 3-axis, horizontal roughing. I'm going to select my containment regions, which is that bounding box that we talked about. I'm going to select a ball mill, and you can do horizontal roughing with an end mill, but I tend to use a ball mill for this. I'm going to select my 1/4-inch ball mill. This whole part's a fairly small part. My feeds and speeds is the same. My clearance plane is the same as 2D. My advanced cut parameters, same. In this particular instance, the performing arc fitting is a little more critical. I want to make sure smooth cut connections, engage and retract. I want to make sure that I have that path to come in at an angle. Cut levels, I'm going to have a step down control. Remember, in the 2D I had a roughing cut and a finishing cut. In this I don't have that kind of control. For this, it's just going to be how far to step down. The smaller this number, the more accurate the cut. In other words, the closer it's going to get to your final model before you do your parallel finishing, but the longer it's going to take. So if I do 50% step over with this, it's coming down 1/8 of an inch each time, which is going to give me several cut levels. If I set this to 25%, it's even going to take longer. So you have to kind of play with this to get as close to the surface as you can, but not having an overly long tool path. Cut levels ordering, I want to do depth first, just like we did with our 2D tooling. Cut parameters, this in toe and out toe are very much like the tolerances we looked at before. We want to set those at 1/1000 so that it comes in at that curve very accurately to it. Stock is how much stock to leave. On 3D cuts, it's much more common to leave a little bit of stock to sand out or to give the finishing parallel cut a little bit to bite into. So I'm going to leave 20/1000. For the most part, we're going to leave cut pattern alone. For cut direction, I want climb milling. Pocketing and linear, we don't need to mess with. For step over control, just like on 2D, that's how much overlap. So I'd like to set that at a closer to 50%. Now with a ball mill, remember the step over will create little scallop lines, so you got to keep that in mind. But this is a roughing pass we're going to come over anyway. We're going to hit generate, and now we're going to go select that. We're going to go to simulate and run the simulation, and there you can see it's cut very close to the piece, leaving a little bit of stock. If I go back and change my depth per pass, it'll look different in the simulation. If I change my step over, it'll get a little different in the simulation.